Hi, this is Mr. Borchard again. We're going to do a tutorial on Euclid's Elements, Book 1, Proposition 2. So, this is the proposition where we are able to recreate any segment that we want, anywhere that we want, on a plane. So the enunciation is to create a segment equal to a given segment with one end at a given point. So the two things that we need are the given point, we're going to call that A, and the given segment. So that would be BC. So what we want to be able to do is recreate a segment that's exactly the size of BC, but it needs to be coming off of point A. And what we're now allowed to do is we're now allowed to just measure this one and stick it there. We need to continually use only the compass, the straight edge, and things that we've proven in the past. Excuse me. So let's get started. What we're going to do is go ahead and connect segment AB as a first part of our construction. Then, off of line AB, we're going to construct an equilateral triangle DAB. So this is using proposition 1, which we just completed. And the quickest way to do it is to make a circle coming off of B and a circle coming off of A. Find the place where they intersect. And that is the third vertex of your equilateral triangle as we proved in proposition 1. Connect that up. And so we have the equilateral triangle DAB right there. And what I'm going to do is I'm going to put in some color so that you guys can see visually that these three sides are related together through congruence. And hopefully this yellow will show up a little bit. So each yellow side is equal to every other yellow side, making an equilateral triangle. Okie doke. Now what we're going to do is continue DA using postulate 1 as a ray in the direction of A. And then this will just go on forever. And then we'll do the same thing with B, DB, in the direction of B. As a ray going on forever. And now we have this diagram. We're going to create a circle from center B with the length of BC. And wherever this line intersects DB, we're going to make a point. And we're going to make that point down here. Even though it intersects DB in two different places, we're going to use this one. And that point will be labeled G. Now, real quick, what segment is BG congruent to? It's congruent to BC because they're both radii of the circle. So I'm going to go ahead and label that right now. So BC equals BG. Now I'm going to create a circle with the center of D and radius DG. So center of D, radius of DG, and oops. There's my circle, and I really only am caring about where it intersects DA. And I'm going to call that point L. Alright, so we've made our construction, and what we want to prove is that BC is the same size as AL, without just putting it down and measuring it. So here's how we're going to go about the proof. We already know that BC equals BG because they're radii on the circle. We also know that BG, big orange line right here, is equal to DL. They're also radii of a circle. That big circle that we made. So DG equals DL. Now, we have to break up DG into its component parts. So if we look at DG, it's made up of two smaller segments, DB and BG. So what I'm going to write is, instead of DG, I can write what it's equal to, which is DB. And you can't see that, so I'm going to write that. DB, it's yellow, plus BG. We're also going to break up DL into its component parts. DL is made up of DA plus AL. So DA plus AL, and AL doesn't have a color yet. Alright, but now we also know that DB is equal to DA. They're both yellow segments from the equilateral triangle. So I can subtract them both equally. It's like this one is 3 and this one is 3. I subtract them both from each side, and all I'm left with is BG equals AL. Now, how can I prove that AL equals BC? I have BG equal to AL, but BG equals BC. So, what I can do is swap this in. Substitute. That is common notion 1, where I'm allowed to substitute things in. So BC equals AL. So all I can do now is go ahead and put this green in there to show that AL is equal to BC. So, to read the enunciation again, and the given and the construction, what I was supposed to do is create a segment equal to a given segment with one end at a given point. A was the given point, and BC was the given straight line segment. So we had to construct a segment congruent to BC with one end at point A. AL is congruent to BC, and one of its end is point A. Q, E, F. We've made it. If you need help with the reflection questions, you should watch the next video.